partial project number 2, we chose the question number 6, which is about modeling data. And well, the problem states that the breaking strength, capital B, in tons of steel cable of various diameters, D in inches, are shown in the table. So our X values are our D, and our Y values are our capital B's. For point A, we have to use a graphing utility to plot the data and graph the model. So here in Desmos, we plot the values, and we have here our table, and we get an outcome of these points. For point B, we have to create an exponential function that models the data.
An exponential function is a mathematical function of the following form, where x is a variable and a is a constant called the base of the function.
With our knowledge of exponential functions and by testing, we found out that this function was the most accurate for our data.
Okay, now for point C, we have to find the rate of growth when D equals 0.8 and D equals 1.5. According to the exponential function that we just obtained, which equals B, which was our initial value of Y, we were going to state it with a B, equals negative 29 plus 25, parentheses, 2.7, and the value of X we had is now our value of D. Now, we have to plug in our 0.8 in order to find the rate of growth at this specific number. So, we have to find the derivative of this B, which will be equaling to dB over dx equals negative 29 plus 25, parentheses of 2.7 of exponent 0.8, which if you plug in the calculator, you will get a total of 26.33. Okay, now we have to plug in our second number, which is 1.5. So we're going to plug in 1.5, which if you put it in the calculator, you will obtain a total of 81.91. So here you have it. You have both of the rates of growth according to 0.8 and 1.5. Okay, so for point C, we concluded that when the rate of change has an x value of 0.8, the total rate of growth will be equaling to 26.33. And when the value of x or d equals 1.5, the total rate of growth will be equaling to 81.91.
To make sure our answers in point C were correct, we come back here in the graph and we can check it right here when our x is 0.8, that it's right here, we have 26.33, so that was correct. And for 1.5, to make sure, we have here that is exactly 81.91. In this project, I learned to apply previous knowledge to solve this problem, and I also learned to distribute the work equally to have final product.
During this project, I developed my mathematical skills using past knowledge of functions.
For this project, something that I learned is how technological appliances such as Desmos could really be of great help when working on projects such as this one that was of modeling data. And also, working in teamwork is of great help, as the more minds, the more information, and the better the product.